Hey everyone, Isaac here, and welcome to the third episode of Between Two Kets, the podcast where we take a peek behind the curtain of the biggest names in the quantum programming community. This episode is going to be a little different than what you might expect because we have cause for celebration in PennyLane turning 5 years old. We don't ever really think about what it takes to make a software package when we're using it on a day-to-day basis. And when you start to think about PennyLane in this context, you can start to come up with a lot of questions from how quantum circuits were chosen to be written in Python with @qml.qnode, why the focus on differentiable programming, and many more things. Nathan Cloran, Maria Schuld, and Josh Isaac were some of the founding members behind PennyLane. They were a huge part in orchestrating version 0.1 of PennyLane, but also the essence of what PennyLane is and what its mandate is. So if you ever wondered how something like PennyLane could become what it's become today, this is the video to watch. Nathan, Maria, and Josh were all in town, and I got to sit down with the three of them to kind of reminisce about PennyLane being 5 years old. We did answer some of those questions about what the essence of PennyLane was and still is, and we also played a really fun game of Pictionary that you do not want to miss. Anyway, I really hope that you enjoy this reminiscing session on PennyLane turning 5. If you like this video, subscribe to the channel so that you know when more of these episodes drop. Like this video if you liked it. And without further ado, here's Nathan, Maria, and Josh. Josh, Maria, Nathan, thanks for joining me today. How's everything going today?
Fantastic. Josh wants to wear shorts.
Yeah. Nathan?
Yeah, excited to be here.
Everybody's in town here. When was the last time you guys were all here, like, together in person?
Last year, I think, like mid-2021, right?
Exactly. I'm even further. I'm in South Africa, so I have to fly through Germany. So it's rare that I can come visit.
So, you're all here. Well, Nathan and Josh, you live in Toronto, but like Maria, you're here specifically for the research retreat. Like, how's that going so far this week? It's the last day of it, but productive, worth it?
Tons of fun.
Yeah?
I've been really enjoying it.
Yeah?
Good to hang out with some really cool people all week.
Yeah. Has it, like, part of the goal of this was to try and like indoctrinate PennyLane into, various relevant big thinkers. Has that been successful on the whole, or like?
I think you got the wrong memo on that one.
Part of it, at least, was like, everybody here's doing research, and whatever tool you're using, like, we had people on standby for like getting them to use PennyLane, or like helping them out with how do I do this in PennyLane, that sort of thing. Like, what was the feedback, I guess, on PennyLane as a whole in this week?
I think the strongest signal is what we got back. So, and that was the intention, right? To understand where we have blind spots. And to me, even from the first moment, there was a couple of big eye openers where I always thought, I never used this, so I didn't think anyone would use this. And then I realized this is super important. And it's sometimes it's very small shifts in like where to put focus in the development team on. That can have a huge impact. So that was super, super interesting.
Even the opposite, right? You can think, oh, this feature is going to be mind-blowing. Everyone will love this feature. And then you put it out there and just no one uses it. Yeah, and everyone's like, oh, I don't need to do that. So I think it's been super useful in that regard because we want to build software that's useful for research. And so by actually having the researchers here and talking to them and trying to implement what they're researching allows us to have that insight.
Let's get to why we're all actually here. PennyLane's turning 5. So like I remember being in school, in kind of like early grad school, and like hearing about all the quantum software, quantum programming, initial hype, and there was a bunch of stuff coming into existence at that point. Qiskit being probably the big one, and then PennyLane all of a sudden popped up kind of when Xanadu was starting to be a thing. At the time, I had like no idea, obviously, what this would turn into, and like obviously now I'm working for the same company, which had didn't plan that at all. But like, yeah, what are your initial thoughts about being here like 5 years later? What's initially going through your head?
Did you notice when we launched PennyLane? Because in those days, didn't have any following. Even Xanadu, was barely out of stealth. Like, did we have a mark on you?
No. So, but not because like I wasn't like my field of research was like kind of totally different. Like I was doing like quantum Monte Carlo stuff, and everything that I programmed was very homebrewed, and wasn't doing any quantum computing for quite a bit. So my first like solid introduction to PennyLane was actually the first Q-Hack, which you're wearing the shirt.
Yeah.
Yeah.
I think you were there.
So that was about like, I probably heard about PennyLane, probably like 6 months after, like beginning of, no, it was, it was QHack 2019 was, I don't know, QHack 2019 was in the fall. Yeah, so it was about 6 months into, like early 2019 was kind of when I figured out.
We had the first QHack about 1 year after we released PennyLane.
Yeah, the dates are kind of screwing with me because like QHack is now like a winter thing, where it was a fall thing. But anyway, so that's kind of when I heard of PennyLane the first time.
When I look back, I always have two worries that I will be found out. I think my first contribution to PennyLane in version like 0.1 was the optimizer module, and I hope it's been overwritten, but I'm always scared someone finds a really bad decision that I made back then.
I don't think it has.
Oh gosh, it might actually be still.
5-year-old
And nowadays we've got like obviously development tools and editors where you can see who made this commit 5 years ago. So, and the second really embarrassing thought is that I think before we started PennyLane, I was kind of tasked as a side project to have a bit of develop kind of a prototype or concept for something like PennyLane, and did completely the opposite how we ended up doing it. So the idea was it was called
QMTL.
OpenQML.
No. It was
the Quantum Machine Learning Toolbox. Oh gosh.
QMLT.
Please don't search for this. I think it might be archived. But the point was, the starting point was completely different. From a scientific perspective, we thought, let's take a powerful framework, in this case TensorFlow, extend it by the things we think researchers want to run on that day. And then PennyLane, and I think Nathan was also very involved in like changing this idea a lot because it was horrendous to program that. PennyLane was completely the opposite. Give a building block or a series of building blocks that are powerful, and then people can decide what they want to run with this in the next couple of years. And when I compare this, I start realizing the power of really building from scratch and building the right things rather than anticipating what software should be like.
So it wasn't just you three who were like the first people involved in PennyLane. There was a couple others. But like, how did you three meet and come together? And like, why, like you kind of touched on it a little bit already, but like, what was the initial reason for wanting to work and build up PennyLane? But first we can start like, how did you three meet and come together and think that this was a good idea?
Yeah.
I mean, we all started within maybe 2 months of each other here at Xanadu. Maria and I had already met previously at some conferences, and very, very memorable. I don't know if there's much science done, but I have lots of good memories of being in the African bush doing like excursions at different conferences.
And had a poster session in Italy where you commented on my poster and told me that extreme learning machines might just be linear regression. My research.
This is before there was QML conferences, and so Maria was talking about like quantum neurons and QML models at like a
Hurons never stuck.
It was a quantum biology conference because that was like the closest analog for conferences. So yeah, we met and we chatted there, and then good fortune, we ended up working together not too long afterwards here. And Josh, you joined pretty quickly after that.
Yeah. I think you guys had already started working on OpenQML, and I could see like whiteboards OpenQML would be written. I was working on Strawberry Fields at the time. I somehow weaseled myself into that project as well.
I know you guys are working on something. I want in.
All right, so you three meet. You've kind of gone through the OpenQML thing, but like, okay, so like you figured out you're going to do PennyLane now. The first thing that PennyLane probably like you needed to figure out was like, what was the initial motivation and layout you had in mind of how to actually like interface what people wanted to put on a quantum circuit, and what should it look like when somebody's typing in Python? Like, what should it look like?
I remember this quite vividly because Nathan and I had a Slack chat where we were just making up fake code that didn't work or exist at the time, and we were just sending it back and forth to each other to be like, would you like coding up something that looks like this? And that's kind of how the user interface discussion started, which happened a bit after development has already started. We'd already built the base, and then after that, we're starting to work out how you program it. And I remember thinking that we were just also familiar with the machine learning frameworks and writing functions, and we wanted to sort of capture that same sort of magic, make it as easy and intuitive to quickly whip up quantum circuits and put together quantum machine learning models.
And I also wonder if a difference was not only a question should have been at the beginning how to implement a quantum circuit, but how to implement a differentiable quantum circuit and a gradient from a quantum circuit. So there were a couple of different design decisions, probably also from that perspective, that what we had in mind was differentiable quantum computing right from the start, and not only quantum computing.
Yeah, I think the function first mentality definitely came in from the start. Even before we decided on the final user interface, I remember very clearly, like, if we're going to have something that is trainable in the same way that these machine learning models are trainable, we have to have functions, and kind of everything is built on top of that basic assumption. For better and for worse, there's certain things that the functional approach does really great, and there's other things where it's a bit more awkward to do stuff.
Kind of feeds into my next question. I guess, has the initial direction changed from what it is now? It doesn't really seem like it's on the whole varied that much, right? Like functions that are differentiable, that's pretty much that's been a mainstay from day one.
Yeah. We want something that started with QML, and we didn't start with like, oh, in QML you're going to do like training set and test set and validation and these are cost functions, because that's what QMLT looked like. It's like, no, what are the primitives? And so the primitive ended up being functions. And so that still holds true today, but now we can take that same primitive and apply it to anything beyond machine learning. We're not stuck with machine learning anymore, because we just got these really cool basic building blocks, and we can apply it to quantum chemistry, to quantum computing, different quantum algorithms. I feel like that approach of starting with the basic building blocks is what allowed us to grow from just a more specific niche QML library to a general purpose quantum programming library.
Who was the first person to type, or at least come up with import PennyLane as QML?
I think
that's two different things, right?
Yeah.
It was very.
I think the actual like strategic decision to have the import shortcut be QML, which is actually convention. Like, you don't have to use it. The program works completely fine without that.
Yep.
Purely a convention. I think that was maybe my suggestion for that one. Just something, so it had to be something short and it had to be something memorable.
It's a bit like, for me, okay, when I was initially, I guess like a couple of years after I kind of like figured out what PennyLane was, and I guess like started using it a little bit here and there, it was a bit of a mind bend once like the QChem module came out and I had to do QML.QChem. That felt very strange. But like now that I'm here and I've been, working with PennyLane for a while, it feels like, just QML.QChem. But when you actually stop to think about it, it's like,
there's a connection though, but it's a bigger interpretation of QML in the sense that machine learning has led to differentiable programming.
Mm-hmm.
The way that quantum machine learning in some sense has led to quantum differentiable programming. So it's a different reading of QML than just like quantum computing for machine learning applications. But it's not it's one of them, but there's other ones.
Slightly nuanced, right?
It's good that we broke your brain a little bit there. That's kind of the point. Like, we want people to, if you're working in QML, these are the natural tools. But if you're working in QChem, hey, here's a new way to think about quantum chemistry. Here's a new way to think about the conventional calculations that are in textbooks. You can go beyond those now. You can train this kind of stuff now. And that was kind of one of the shifts we wanted to put in people's minds. It's not just a QML idea.
Actually, even thinking about the UI, it wasn't just the functions, which was like something we wanted to do from the start, but measurement primitives was another thing. Because I think up until that point, every quantum software framework, it just returned samples and you had to deal with that yourself in post-processing. And the first version of PennyLane actually didn't have samples. The primitive you returned from a quantum function was expectation values. So that was also something that we kind of took in the sense of, if you're doing differentiable quantum programming, we need the output to be somewhat deterministic in the sense of we need the gradient to be well-defined. So it led us down the sense of the statistics that you're returning from the quantum hardware itself is potentially a primitive as well.
It's hard to believe that was like a novel thing, because nowadays it's just such an obvious thing to do, right?
Okay, so you start working on PennyLane behind the scenes for a bit. Like, what was the threshold for releasing version 0.1? Like, and what did you do when it went live? Did you celebrate, go to sleep? Like,
I don't remember.
I
remember we went out for pasta to celebrate. You weren't, unfortunately, not there, but it was Josh, myself, and Billy, who was the first programmer who was developing it with us. I don't know if there was much fanfare other than that.
It didn't feel like a big milestone. I remember we made it public, but...
I mean, that's the honest thing. Like, if you don't work with releasing stuff and building products, you don't kind of recognize this, but releasing is actually the start. And so it's good to celebrate that milestone, but if you want people to use it, you have to keep developing it, keep maintaining it, keep putting out new interesting things, keep advertising it, keep creating content.
Were there things that you were, was everything developed pretty much simultaneously? Like, I guess what I mean, for example, is, did you just have the code base for PennyLane ready, and then you're like, oh crap, we need documentation? And then Josh, you like learned everything, the ins and outs of Sphinx, and you were just like, that's what you did. Is that at all accurate, or?
I would say no. We had the code base ready. We'd been working on the integration. So I say the way we did it was theory first. Like what's the theory of quantum gradients? How does that tie into integration with other frameworks? And then came the code base to do that. Then came the user interface. And I remember there was a distinct period of weeks. So I think it was yourself and myself, Maria, where we were working on 5 tutorials that we wanted to launch with. So there was the qubit rotation one, function fitting. And I think from the very beginning, we were like, documentation is important because you can't just release something and expect people to find it and use it, but you need to show people what you can do with it in a way that is intuitive and explains what you can do with these building blocks.
Even at that stage, the theory wasn't all there. If you think about, so for example, the idea of getting gradients out of a quantum circuit by these things that we now call parameter shift rules, they came, I think, from quantum control in a paper that got very famous afterwards. And I think then we generalized it. So this was not even, it was just a 1-sentence statement that I think also Nathan, looked at it and said, this is the foundation of a whole future of software, right? And then, for example, what we did, we started to see, okay, is this a general tool we can use? We actually gave it the name parameter shift rule, and then also saw in other frameworks like continuous variable quantum computing, can you use it? And these ideas had been going around, but not in a way that you could just go and say, this is theory, let's implement it. But at the same time, the research was done, the software was actually created. So that's interesting, and to see that interplay, I think, is still playing out today. Yeah.
You were one of the people tasked with writing the white paper that came along with PennyLane. You told me at one point, hey, we should split this off. This notion of the parameter shift rule is its own idea, and we should highlight it separately as its own paper. Of course, it's based on some observations from other papers, but we kind of realized the scope and the scale that this thing could have impact for, and that became its own paper.
So I have a question then. Where does the name parameter shift rule come from? Who coined it? Because someone asked me this the other day and I didn't have an answer for them.
I think I invented it. The Curon didn't stick. Parameter shift. I hope no one disses me now in public, but I'm pretty sure in that paper it's used for the first time, at least that I saw it, and then it was just you're shifting your parameters.
Did you intend for it to stick, or was it just I'm just describing what we're doing?
No, it was actually there's another word that I think I can claim I invented, although I know people will say that I won't, and that's amplitude embedding. And there was the same story. People use something and they talk about it, but every time they talk about it in scientific discussion, they have to explain what they actually mean, or they have to write it down. I always think okay, just put a name out. It doesn't even matter which one it is. Another one that I definitely didn't invent is quantum neural networks. And then now it makes it so easy to use that everyone uses it, even if it's not a good name. So yeah, that was not so much marketing than need.
Okay. So these are going to just be some fun questions about PennyLane. The first part is going to be a game. Hopefully you guys are all familiar with what Pictionary is.
Oh no.
No.
No? Yeah? Yes. You do know what it is, but you're dreading it? Nathan, you know what Pictionary is,
Yeah,
right?
but Maria gets to go first.
Okay, so I had to write down all the words that you have to write, but how this is going to work is basically it's just a free-for-all, but whoever is drawing and whoever answers it, you'll both get a point. So yeah, that's kind of how it'll work.
Do we just start guessing straight away?
Yeah, okay. Yeah, and you have 60 seconds, and if there is a tie, there's a tiebreaker.
What are we competing for?
The
points don't matter.
Points don't matter.
That's unfair because Josh is the informal in-house designer of.
He's got a head start.
You're right. Yeah, but I don't know how well.
But you have to be guessed.
I'm out of practice though.
It's all about efficiency, right? You have 60 seconds, so you just need to get something. It doesn't have to be
It's not about artistic value.
It's just about how quickly can you get the point across.
Okay, cool.
There are things over there. Don't look at the other ones. Just pick one, and just let me know when you're ready.
No.
And
there's no way I can draw this. I can't write words, right? Even if it's unrelated.
Yeah. Okay. So the rules are. Yeah. No. So no symbols.
What about a ZX diagram?
Yeah.
Okay, I'll go now.
Okay. 3, 2, 1, go.
User.
Gingerbread man.
Robot.
Teleportation.
Angel. Sign.
Parachute. Stop sign.
Oh gosh.
Oh god,
Operator.
This one's really
Operator.
Oh man.
close.
Operator sign, operator.
Hamiltonian.
Um,
Smooth operator. Cactus. Turkey.
chicken, duck,
Turkey.
Duck operator.
Bird.
That is a duck. Though.
Can I cheat and put some letters?
PennyLane.
We got
operator,
5 seconds left.
Okay.
Street, stop street.
All right. Okay. Time's up. Maybe I wasn't like super clear. These are all PennyLane features, so it's not just like random, whatever. But anyway, so
You never heard of the turkey module?
the turkey module.
So what are these?
I was trying to draw Grover from Sesame Street.
He doesn't look like that.
Okay, just let me know when you got it figured out. Okay.
Oh, no, I don't have it figured out.
Okay.
I think it's unfair to wait. Okay, yeah.
Okay. 3, 2, 1, go.
Archery Falk.
State preparation.
Amplitude embedding. Grover operator. Superposition. Schrodinger's cat.
Ansatz. Circuit ansatz.
Almost. Yeah.
Data embedding. Amplitude embedding.
Wait.
You guys are super close.
I mustn't draw a symbol, right?
Pi?
But,
Angle
Circuit
embedding.
embedding.
Yeah.
Josh got it. Angle
that wasn't
embedding.
either one.
Okay, so Maria and Josh get a point. You got it?
I'm ready.
You ready? Okay, 3, 2, 1, go.
Template, tape,
Circuit ansatz. A laptop. PennyLane. Keyboard.
a program, quantum program,
Internet.
code base, codebook, quantum codebook.
There you go, code book.
Ah, damn it.
I'm ready to go.
Okay, you ready? Okay, 3, 2, 1, go.
Circuit,
Teleportation.
ansatz, beam splitter,
Mid-circuit measurement. Swap test.
Hadamard test,
Swap gate.
cherry,
Swap gate.
joking, the swap operator.
Okay.
Circuit cutting.
Yes.
Yeah, there you go.
Good one.
Okay, 3, 2, 1, go.
Cat.
Whale.
Whale.
Embedding.
Other one.
Schrodinger's pets.
Oh, classification.
I'm a little confused here too, actually.
Circuit classified.
Data sets.
Yeah.
Oh.
How did you know that it's plural even? Because only one.
Good job.
These are multiple boxes with weird things in them.
Go.
Lightning.
Lightning qubit.
Lightning BP. Oh, damn it.
Lightning qubit.
As soon as I saw the zigzag, I was like,
Can we
oh.
both get half a point?
If you, sure.
I surely
Share the
wouldn't
point.
have ever guessed that this is a lightning.
3, 2, 1, go.
Parameter shift rule.
Yes.
Wait, you
What?
guessed his mind, not his drawing. Well
I
done.
figured we were due.
2, 1, go.
Neural network.
Recurrent
Feedback.
neural network.
Mid-circuit measurement.
V. Arrow. Huh?
Just layers.
Hidden layer.
Backpropagation.
There you go. Right on.
Oh.
Go.
Chop, axe, cut, chopper block, wood chopping, a trunk,
Wood.
truncation,
Lumberjack.
Nathan's cottage, computer,
So close.
program, cutting, program,
Circuit.
debugging, So program that we had before.
But why are we chopping
Program wood program. Trunk.
log?
Log.
Oh,
I'm looking.
That's a tie right there.
I think Josh got the word out there first. Go load up on Bubly. That's maybe a good question. What is everybody's favorite type of bubbly?
Favorite bubbly? I like the peach.
Peach.
I've never had a bubbly.
You gotta try one.
I had pomegranate. Was nice.
Pomegranate?
Pomegranate.
There's no pomegranate.
Wait, grapefruit.
Grapefruit. I like the grapefruit one. That was a little underrated for me. I go for blackberry if there is blackberry, and then I like the pineapple one too. That's a good shout. Okay, cool. Now we kind of alluded to this a little bit earlier, but what was the biggest mistake or bug that you accidentally or intentionally put in PennyLane? And it could be something like, I'll just add this like temporarily even, and then it like stayed forever. Like, what's the biggest gaffe you can think?
I think one of the first templates was called Strongly Entangling Layers, and it's from a paper. It's basically just implemented because it's from a paper that I once wrote, and I thought, okay, the easiest for me to code up is that one.
Mm-hmm.
And then everyone started using it everywhere, so it's in every test. It's now also in lots of papers, and I'm pretty sure that they were not just impressed by our idea back then in the paper, but it's just there in PennyLane, and it has just like gone. And I feel sometimes a bit responsible for people using something that I'm not sure. I'm sure it's a nice ansatz for quantum circuits, but I'm not sure if it should be so popular.
I think it's because it just sounds really useful. Like if you're looking at the list of templates in PennyLane,
It's like strong.
yeah, I want something strongly entangling.
Someone told me it actually also behaves well under certain circumstances because it's very big and it's useful for testing, for example. But
Okay.
I'm always, when I see it, I always think they use it because they think I made a decision there with gravity and gases. But it was for me just like thoughtless. And this is also when
Right.
I realized how much the design decisions you make when you create software, people actually use them and don't often think about them. So you have to approach this a bit more with responsibility.
I think something that has stuck around that has surprised me has been the name of default qubit. Back when we named it, I remember trying to make the decision. I was trying to just name it something very boring, because the more boring the name was, the least likely people would use it, because it was just meant to be a reference Python simulator.
Right.
But it became so popular just because it was there. It was the simulator that came with PennyLane.
What's your favorite emoji to use in the Slack channel we have, or like what's the one you dislike or get confused by the most?
I'm a big fan of
Cyclops.
Cyclops is my thing.
Right.
Yeah. Cyclops. Isaac, I know you're a bread man.
Oh, yeah.
I like the bread as well. For all those viewers out there, emojikitchen.dev. You can thank me later.
Yeah.
I would say my most used one is Thinking Face, because it's always useful.
It's universal.
Yeah. Someone says something you don't know the answer to, Thinking Face.
Thinking face. Yeah, okay. Now I know that, because sometimes I'll write something, then Josh will react to it, thinking face, thinking like, is this guy serious? Is he like seriously asking this question? I kind of maybe think of it as like a condescending thinking face, but no, now I just know that it's your just default one. Okay, cool.
I also like that one because it's nice also for slight criticism where you don't want to be mean to someone, where it's kind of like, I'm just not sure if this was the right approach. But the one I get myself using more and more often is the one, I don't even know, I always go into the list and pick it out, but where it has the like, the teeth.
Grimacing.
Yeah, because sometimes like,
I like
a meeting
grimacing.
shift, or I have to barge in on someone, or mess something up, then that's a very nice one to be, but like, sorry.
Sorry, yeah, okay, cool. 5 years ago maybe doesn't seem like too long ago, but like, here's some things that were happening in the world in 2018.
Oh no.
The Yanny versus Laurel thing. I don't know if you've ever heard that sound bite. I can pull it up.
I think you have a different like cultural
This is very
reference.
North American, so
Clearly saying Yanny.
I can hear both. I've trained myself to
What's
hear
the other
both.
one?
It's Yanny or Laurel.
Are you joking?
I'm not joking.
It helps if you see it written down. Like if you're reading the word Laurel while hearing it, you hear Laurel.
Okay, so I guess we really haven't touched on it too much. A little bit. PennyLane's community is awesome, and we've got great content like outside of the software we develop. What's a demo or a blog that you're the most proud of? Like, could be the VQE one, which is probably our most searched and clicked on one, but what's one in particular that stands out for you guys?
There's some real hidden gems that you wouldn't know are super popular. Every year is in the top 5 most visited pages on the entire PennyLane website is a demo with the Har measure.
Yep.
Apparently people are just going there like every day because it's the best resource. You can't find this material in a paper. It's used, but it's never explained properly. And so just that content that fills those gaps, that there's no other resource out there, when we can find those things, that, those are the things that I'm most proud of.
The demo I'm most proud of, I think, is the QNG demo, partly because of how it came around, in that I wrote the quantum natural gradient demo at the same time we were working on the paper. When you're writing a demo with code, it's kind of different to writing a paper. You want to sort of work from first principles, show the reader how you're building up this new idea that you've come up with in a way that they can sort of reproduce it and then extend it and generalize it just by copying and pasting code. So I really enjoyed that, and something that stuck with me as we kept writing more demos.
I had a demo that I was super proud of, which was on quantum embeddings and metric learning, and then I realized there was a bug in the data set that I produced. Then I tried to fix that bug, that was many years ago, and realized that nothing works anymore. I couldn't fix it, I had to take it down, and now every now and then someone asks me for the code, and I'm always like super sad and embarrassed. And
so what part of the industry do you think PennyLane has changed forever? Like in other words, like if there's one thing, like let's say, 50 years from now, PennyLane somehow just like stops being developed or something. I don't know, something catastrophic has happened. But what's going to be that lasting impact that PennyLane had, do you think?
I feel like we never want to stop. Like maybe we have to give up one day, but we should be every year thinking about what's that new thing we can add. Like I don't want to feel like, hey, we had some success with this one thing, everyone's using that same idea now, we can rest, we're happy. I feel like it's a good sign when people you start seeing the same idea come back to you. Other people are putting it in their software, but you always want to be one step ahead. You want to be thinking, okay, what's the next problem? Because we don't have quantum computers yet, right? We need to get there still. So how do we continue to innovate, continue to pioneer every single year with new ideas? That's what I'd be most proud of, is more the spirit of continuing innovation.
I would say I'm also proud of the fact that it's just been a contribution to the open source quantum software community as a whole. It's shown people that they can contribute to open source. I think has also inspired and helped grow a broader ecosystem of quantum software. It's not seen as a distraction to build software when you're doing research, but it's a positive. It's a tool that helps you with your research and helps other people as well.
I think it's important amongst the tools that make us test the idea of variation circuits in all sorts of corners and by all sorts of people on a large scale. And I think that's almost like an optimization or a search that lots of people have to do because it's so difficult to access like the scales that we're actually interested in.
All right. Yeah. Well, I think that's a good place to end it. Thanks so much for joining me, guys. And have a good rest of your week. Maria,
Sorry.
You had to redo this ending. So.
Oh no, I just remember thinking, try not to laugh.
Oh my God. Okay, we're done.
So you don't know what the Sesame Street character is. So you don't know what the actual algorithm is.
My least favorite one's probably
Jerry.